Hello, welcome to our next session or topic in securing cyberspace. Today I have a special guest, Bastian Hofmann from SUSE, and we are talking about Kubernetes security and cluster security. Please introduce yourself, Bastian, and tell us what are the main challenges in Kubernetes security and cluster.
Yeah. Also, hello from me, and thanks for having me. My name is Bastian. I'm a field engineer at SUSE, and my main focus is on our whole enterprise container management portfolio. So, Rancher, Harvester, Longhorn, K3s, New Vector, everything that has to do with containers and Kubernetes, basically. Our topic today is security challenges, specifically in Kubernetes environments. Why are we talking about this? Nowadays, containers are a critical IT priority. More and more applications are being developed and are being deployed to production in containers. And these are figures from Forrester. They're even 1.5 years old, so not accurate anymore. And even then, lots of developers already had visibility with containers, have been using them somehow. On the other hand, only 10% of the applications out there running in productions are currently running in containers or were currently running in containers in 2021. Though important, this number is expected to grow quite significantly every year, and more new applications and existing applications get ported and get migrated to run inside of containers. And oftentimes, when running containers in production means running them in Kubernetes as a container orchestration platform. The great thing about Kubernetes is that it creates a common compute platform that works the same regardless where you want to run your applications. You can run Kubernetes on your developer laptop, in the data center, of course, on cloud providers as managed services or just on VMs. But you can also use and run Kubernetes in more non-traditional use cases, IoT and edge use cases, where you have some industry PCs in a factory or some servers in a supermarket branch, or maybe some industry PCs that are in 5G cell towers or in windmills or in cars or in satellites. Everywhere where you want to manage software, Kubernetes can help to bridge all the differences between the underlying architecture and the underlying infrastructure and create a common platform with standardized APIs. And here, Kubernetes not only cares about starting and stopping containers on a bunch of machines, it also cares about setting up networking between your applications, configuring health checks, load balancing, security policies, service discovery, auto-scaling, role-based access control, backup and disaster recovery, and much more. And for all of that, you have standardized APIs so that you don't have to reinvent the wheel every time you deploy something to a new infrastructure. Of course, you can imagine this also can create some challenges, especially in terms of security. Again, containers are becoming more and more prevalent, and this is done very rapidly, which means a lot of the traditional security tools that the security departments and ops departments are used to, they don't work in these environments that well anymore. One of the beauty of Kubernetes and containerized applications is that you can start an application on one server, and when that dies, it's automatically rescheduled to another server. Or you can scale in a very agile way applications up and down, and it doesn't matter really where they run, they should just run somewhere. Traditional security tools, though, expect a much more static and less dynamic environment and can't cope with all this change that is and all the agility that you see in Kubernetes clusters, and that are the benefits why we're using them. An additional challenge is that it's on the one hand great that Kubernetes abstracts all the networking aspects away from you and it just works as you would expect. But that has a trade-off that you also have a lot less visibility inside of the container network. And again, traditional security tools basically only tells you what's happening outside of the cluster, but not inside of the cluster. And all these challenges are then even becoming more problematic if you're not only managing one Kubernetes cluster or maybe two Kubernetes cluster in your organizations, but maybe more of them. And when we talk with customers, we quickly see that a lot of customers are not only running 1, 2 Kubernetes clusters, they quickly end up with like a dozen or 2 dozen, or sometimes also hundreds or thousands of Kubernetes clusters in the whole organization. It could be, for example, that they are saying, okay, we want to strictly separate development from staging from production. That would be already 3 clusters. And then maybe you have different development teams and you want to have these development teams to work autonomously so that if development team 1 breaks some cluster because they tested something, development team 2 can still continue to work. So maybe you actually have a Kubernetes cluster per development team. And then in production, maybe you have multiple data centers. Maybe you have to split workloads up because of regulatory reasons. Maybe you want to run some workloads in the cloud to scale out. Others need to be on premise because it's much cheaper to run them there, or the data is very sensitive. And especially when we come to the edge space, where you run Kubernetes clusters on industry PCs in factories, in trains, in self-driving cars, in satellites, you can imagine we quickly talk about thousands and tens of thousands and millions of clusters. Additionally, because you have an open standard and because Kubernetes is so ubiquitous nowadays, it has become a prime target for attackers because in a standardized API that's run thousands and tens of thousands and millions of times in the world, if you find a vulnerability in Kubernetes, you can get into a lot of clusters. So if you speak about security, we definitely have to also secure our Kubernetes clusters. And things to consider there are who actually has access to the Kubernetes API and the cluster itself. How do you configure role-based access control? How do you do certificate management, both for the Kubernetes internal certificates that Kubernetes uses for its internal communication as well for your applications? How do you do version upgrades so that if a new Kubernetes version comes out with some critical patches, that you are quick to actually apply them? How do you configure admission control to configure which Kubernetes resources and workloads can actually a developer deploy and maybe restrict the things they can do? How do you configure security network policies to also restrict what applications inside and containers inside of the cluster can do during runtime? And how do you do encryption, both of the traffic and also of the Kubernetes database and maybe even of your persistent storage at rest? But it's not only about the Kubernetes cluster itself, it's also about your applications. Because also there, in your containerized applications and in the container images you build, there can be lots of security vulnerabilities. It could be that your containers just request way too many capabilities. Does your application really need to access the network stack of the host machine? Does your application really need root? Maybe there are already known CVEs in the base images that you're using for your containers, in the packages you are installing there, or maybe in the frameworks and libraries you're using in your software. Maybe your container images have compliance issues, things like configuring directory permissions way too broad, or things like storing passwords and certificates directly inside of the container image. That could also be a security risk. And maybe it's just a bug in your software that can be then exploited.
So Kubernetes cluster security is very complex and challenging, and you mentioned the old tools are not working anymore, but these challenges need to be solved. And that's why we are talking about tools and solutions out there that helps securing clusters. In the next episode. See you there.